Hello, everybody. We're going to talk now about chemical equations. Chapter 10 is all about chemical reactions and chemical equations, but we can't really talk about them until we know what to do with them. All right, there we go. Let's start at the beginning. Okay, so a couple of definitions, or at least one definition for you. A chemical equation is an expression that we use that shows the reactants, the products, and other information when describing a chemical reaction. There's a lot of information in a chemical equation, so let's cover some of these things. First of all, let's go over the symbols that we use. To separate individual products or reactants from one another, we use the plus sign. To separate reactants from products, we use the single-headed arrow. Now, in general, this arrow is pointing to the right, but it doesn't have to. It always points to the products, however. Now, products of a reaction are the things you get. You can think of a chemical reaction like, say, a recipe. The ingredients in a recipe are like the reactants. The final product, your chocolate chip cookies, those are the products. Okay, there's another kind of arrow that we also use sometimes, and this is this double-headed arrow. We won't use it for a little while. The double-headed arrow separates reactants from products in a reaction that is reversible. Reversible reactions are very, very common, and we need to discuss what that means later on. So I just want you to notice that symbol and know what it means when we get there. All right, now we have the state symbols. There are several state symbols, and they tell us what physical state something is in when it is reacting or has become a product. So, first of all, we have lowercase s. Lowercase s means solid. Pretty obvious. The next one we have is lowercase l. Now, I've done this in cursive just to denote the difference between a lowercase l, the number 1, and a vertical line. Okay? So you won't always see this written in cursive. When I write it by hand, I do it in cursive. But often in books, you might not see it that way, and you should just be aware of that. Okay, so the L means liquid. Now, liquid is something different from a solution. Most of the liquids we come in contact with in our daily lives are actually solutions. But the L for liquid means a pure substance like pure water or mercury metal. It is not a solution. H2O with a sub of the state symbol L means it's pure water molecules with nothing else dissolved in it. Okay, lowercase g, you probably could have guessed, means gas. And this last one, lowercase a, lowercase q, means aqueous or aqueous. Different people pronounce it differently. And basically, it's a solution in which water is the solvent. Now, solutions are a mixture in any phase of matter. Even solids can be solutions. Alloys, for example, are solutions of different metals. The air we breathe is a solution of different gases. Okay, so solid, liquid, gas, and aqueous. Those are our 4 state symbols. Moving forward. Okay, now this is how a chemical equation is actually written out with its different parts. So I'm going to walk you through this chemical equation first. What we have here is nitrogen in its gas form combining with hydrogen in its gas form to form ammonia in its gas form. This is a really important chemical reaction called the Haber process. It's very important for a couple of reasons. One of which, the most important reason, is agriculture. This is the way in which we produce basically fertilizers, nitrogen-bearing chemicals that plants can use. Also, ammonia used to be used as a chemical refrigerant. And maybe some other time we'll go into some details on that. Okay, so the Haber process again combines nitrogen with hydrogen to form ammonia. But it tells us more than that. The obvious parts are the plus sign separating the nitrogen from hydrogen, the arrow separating my reactants from my products, and then we have, of course, our state symbols denoting what physical state my reactants and products are in, and they're not always in the same physical state. They can be different. And we also have coefficients. You'll notice this 2 in front of ammonia, the 3 in front of hydrogen, and there is nothing written in front of nitrogen. Now, the 2 and the 3 mean what you think. There are 2 molecules of ammonia or 3 molecules of H2. This blank space in front of the N2 means the number 1. But just like in algebra, we don't write the term 1x or 1y. We leave it blank. The 1 is, it's implied, and that's true in chemistry as well. So there we go. There's a nice chemical reaction. Now, before I move on, I want you guys to try something for me. I want you to take a look at this reaction. Now, of course, I've written the answers below, but I want you to try to name the reactants, name the product or products, and tell me what phase of matter are the reactants and products